Well, hello, hello. This is College Algebra Unit 1 Review A. And welcome, welcome, 2014-2015 College Algebra students. This is Mrs. Carlson, and we're going to work each problem for you, and I'll explain my reasoning. And please give me feedback. Let me know what you think. And if you think these help you, please let me know that too. So number one, it says solve by factoring. And so anytime that I want to solve a quadratic, I know it's quadratic because of the exponent, it's 2, that I want to set that equal to 0. So the first thing I have to do is subtract the 32 and move it over to the other side of the equal sign. So I have x squared minus 4x minus 32 is equal to 0. And then I'm thinking about what's going to multiply to give me a negative 32 and what's going to add up to give me a negative 4. And I know that those factors are going to be a negative 8 and a 4 and a negative 8 and a 4. So they multiply to give me a negative 32 and add up to give me a negative 4. So I can set that up right away by x minus 8 and x plus 4. So those are the factors that I have for that. And then I set up my little equations. X minus 8 is equal to 0, x plus 4 is equal to 0, and then I proceed to solve them. So I add 8, and so be sure that you know that you're solving these. So you want to have x is equal to answers. You don't want to leave them in the state of in factored form. You want to make sure that you are solving them, and so your answers are, let's see if I can do the spotlight pen. So this is how you have the answers, okay? You want to make sure that they're in the form of x equals. Number 2, again, a factoring problem. We want to set it equal to 0, and so I'm going to go 6x squared plus 17x plus 5 is equal to 0. And so now this one I need to use master product. I'm going to multiply the 6 and the 5 together. I'm going to multiply those two together. And 6 times 5 is 30. So something times something gives me 30. And something plus something gives me 17. And so things that I think about are 2 and 15. 2 and 15. So I have 6x squared plus 2x plus 15x plus 5, and that's equal to 0. So you can see here that the 2 and the 15, those are equal to the 17x. And so I want to make sure that you know that I'm not changing anything, I'm just rewriting it. And so I'm going to take the plus 2x and the 15x there, and I'm karate chopping it, and then I'm going to factor by grouping. So what is common with 6x squared and the 2x? Well, that's a 2x. And what do I have left over? Well, I'll have 3x plus 1. And I can factor a 5 out of the other pair, and what do I have left? 3x plus 1. So I know that I'm on the right track when these are both the same. Those are both the same. So therefore, I know that I can continue factoring by grouping with this. So let me get this out of there. And so now I can rewrite it as 2x plus 5. Those are both the outer ones, times 3x plus 1, the quantity of 3x plus 1. And so now I have those little equations that I can solve. So I have 2x plus 5 is equal to 0. 3x plus 1 is equal to 0. 2x is equal to negative 5, so x is equal to a negative 5 halves. 3x is equal to a negative 1. X is equal to a negative third. And so those are my two answers that I have for that one. Number 3. I want to solve this by taking the square root right away of both sides. I have a binomial here that is squared, so I want to just get rid of it with square root. So that leaves me with x minus 8 is equal to plus or minus the square root of 22. You need to remember that it could be a positive or a negative anytime when I take the square root. And so now I'm going to bring the negative 8 to the other side. I'm adding 8 to both sides. So x is equal to 8 plus or minus the square root of 22. So that's number 3. Number 4 is similar to that, so it's the same thing. Take the square root, take the square root, the square and the square root go, and that gives me 5x minus 2 is equal to plus or minus. Now, what is the square root of 36? The square root of 36 is 6. So now I have two equations here that I can deal with. I have 5x minus 2 is equal to a positive 6, and 5x minus 2 is equal to a negative 6. And then I have 2 that I can solve. So add 2, 5x is equal to 8, dividing by 5, dividing by 5, so x is equal to an 8/5. Adding 2, 5x is equal to a negative 4, divide by 5, divide by 5, x is equal to a negative 4/5. So there we end up with our two answers again. Becomes quadratic. Number 6, absolute value. Oops, excuse me. Number 5, absolute value. Can I ever have an absolute value in here that is equal to a negative number? Am I allowed to have an absolute value equal to a negative number? Not possible. Absolute values are always positive. So the answer for this would be no solution. Absolute value cannot be equal to a negative number. Okay, so you better remember that. Okay, this one though is equal to a positive 10. So we got to start peeling stuff away. I'm going to add 8 and add 8. So I have 3 times the absolute value of 5x minus 1 is equal to 18. So then remember that the 3 and the absolute value sign right here, they're right next to each other. And when they're right next to each other like that, that means that they're being multiplied. I want to undo multiplication, so I'm going to divide. I'm dividing. Absolute value of 5x minus 1 is equal to 6. And now I can do my two equations. So I'm ready to take off the absolute value, and I have 5x minus 1 is equal to 6, and 5x minus 1 is equal to a negative 6. I have two little equations to solve. 5x is equal to 7, divide by 5, divide by 5, x is equal to 7/5. Add 1, 5x is equal to a negative 5, divide by 5, divide by 5, x is equal to a negative 1. All right, we need two answers. Here I have a radical. I would like to isolate the radical. So I'm going to add 5, the square root of 3x plus 4 is equal to 5. So now I'm going to square both sides. The square and the square root go, and I have 3x plus 4 is equal to 25. Subtracting 4, 3x is equal to 21. Divide by 3, divide by 3, x is equal to 7. So I need to take 7 and I need to make sure that it works out okay. So I have 3 times 7 plus 4 minus 5 is that equal to 0. So 3 times 7 is 21 plus 4 minus 5. We're testing to see is that equal to 0. So that's the square root of 25 minus 5 is that equal to 0. So 5 minus 5 is 0. 0 is equal to 0. So this checks out. So my answer is okay. Therefore, it's not extraneous. Over here, I want to separate this. I want to keep this here, and I'm going to have the square root of x minus 5. It doesn't look so hot. So let's try again. Square root of x minus 5 is equal to 5 minus the square root of x. So now since I have two radicals, one on each side, I'm going to have to square them. So the square and the square root, and that gives me x minus 5. So 25 minus, so that's going to become a negative 5 radical x, double it, a negative 10 radical x, and radical x times radical x, that's going to be a positive x. Now remember, if you are uncomfortable with the pattern, you can do this and write it out 2 times. And you can distribute it so that you end up with the same thing. Okay? If you get the pattern in your head, though, that's going to help you for the rest of your college algebra days. So I'm subtracting x, subtracting 25, subtracting 25, and I end up with a negative 30. That goes, that goes, that goes, is equal to a negative 10 square root of x. I'm going to divide both sides by negative 10, negative 10. So that becomes the square root of x is equal to 3. And now how do I get rid of that radical? I'm going to square this side and square this side. So x is equal to 9. So I need to go back in and I can check my answer. So I have the square root of 9 plus the square root of 9 minus 5, and I'm checking to see is that equal to 5. So that's 3 plus 9 minus 5 is 4. Is that equal to 5? And so what is the square root of 4? That is 2. And so is 5 equal to 5? Yes, it is. So my answer is okay. On number 9, it's asking me to sketch a function that has exactly 3 zeros. And so you want to have something here that is an x and a y. So, and to have exactly 3 zeros, what does that mean? That means that I'm going to have my line cross the number line, or my x-axis, in 3 spots. So if I have something like this, I'm going to come up, and I'm going to go up, and I'm going to come down, and I'm going to come up again. And so is that going to satisfy that? I have 1, 2, 3 zeros. 3 zeros. Number 10, sketch a function that has no zeros. No zeros. So this is, we did this a long time ago when we first started with square root, and we did a solution with no zeros. So here's an idea of something that goes like this. You certainly could, let's see if I can clone this. Let's move it over. I'll do another example. And let's clone it. And I'll get rid of that one. And what if I did something like this, where it's a parabola, but again, it's not crossing. If I moved it up, that would have a 0, but since it's not crossing the x-axis, that's another example with no zeros. Okay, something like that. So I'm going to write the interval notation on a number line. And so here is my number line. And I have a point at -2. It's a less than. So I know it's an open circle, and I want all the values that are going less than. So -1, 0, excuse me, -1, -3, -4, -5, etc. So I need to write the interval. This graph begins at a -infinity. And let's see how fast I can get my box. So then that way I can have the box. This is my box. I saved it. I'm going to pause this for a second. Okay, so I have a box, and as I drag this box across the line, it begins at -infinity, and where does it stop? It stops at -2, and so I have to do end marks. End marks for infinity are always going to be a parenthesis, and end marks for an open circle, which is a less than, is also a parenthesis. And so that's my interval. I'm going to take a second and just paste these on here so I have them in case I need them. Okay, I think I'm good. So here's my number 12. And so I need my number line. And so here's my number line. And so all I care about at this point is the critical point of 7. This one is a greater than or equal to, and so that tells me that it's going to be a solid dot, and greater than is to the right. And so where does my graph begin at? It begins, oops, this to the front. So where does my graph begin at? It begins at 7. Where does it go to? It goes to infinity. End mark for infinity is always a parenthesis. This time I have a solid dot. And so what does a solid dot mean? It means a bracket. It's included. It's part of the graph. And so that's going to be a solid dot. Number 13. So I have my line, my fabulous, good-looking number line. I have the points at -3 and 10. Over here, this is reading going this direction. It says x is greater than or equal to 3. So I'm going to have a solid dot, and it's greater than, which is going to the right. Now, when I read this direction for x, I'm going to go this direction, and it says x is less than 10. It's an open circle. Less than 10 is going to the left. And so as I look at my box, I'm going to cover up my box. Oops, I thought I did order in the front. So here I am at the front. Where does my graph begin at? It begins at -3. And where does it go to? It goes to 10. What kind of end mark do I have at -3? Well, that's going to be a bracket. It has a line underneath it. It's a solid dot. And at 10, it's a parenthesis, an open circle. And so hopefully that you're beating me and you're doing these ahead of me. And you get them right. And so now here I have critical points of 0 and 5. And so this is saying that I want all the x values that are less than or equal to 0. So less than or equal to, solid, and it's going in the less than direction. Number 5 is just a greater than, that's an open circle, and it's going to the right. So now when I look for my inequality, I drag it across, and I start at an arrowhead. That means negative infinity. And where am I going to? I'm going to 0. What are my end marks? Parenthesis and bracket. I have more on my number line though, so how do I say more in math? Union, and I'm starting at 5. And where am I going to? Arrowhead here, and so what does that mean? Infinity. And so that's an open circle, and infinity is always a parenthesis. So there we have all of our intervals. Now we're going to absolute value inequalities. And so for number 15, we want to first isolate the absolute value. So I'm going to divide by 5, divide by 5. The 5 is being multiplied with the absolute value, so I want to undo that. So I'm going to divide. And so I have absolute value of 4 minus 5x is greater than 3. And now I'm going to write two inequalities. 4 minus 5x is greater than 3. So it's the same exact inequality. And 4 minus 5x is less than a negative 3. And now I have two inequalities to solve. So subtract 4, negative 5x is greater than a negative 1. Divide by negative 5, divide by negative 5. X is, I'm dividing by a negative 5, and so that's going to be less than 1/5. I'm going to subtract 4, negative 5x is less than negative 7. Divide by negative 5, divide by negative 5. X is, since I'm dividing by a negative, I have to reverse the inequality sign, and that's going to be a 7/5. So now I'm going to draw my number line. I have two numbers. I have 1/5 and 7/5. which is the same as 1 2/5. So either way, I have the first one over here is x is less than 1/5. So open circle, less than. This one is saying I want x is greater than. Open circle, greater than. And as I look at my inequality, I'm going from negative infinity to 1/5, parentheses, union, 7/5 to infinity. And that's number 15. Number 16, again, I have another absolute value inequality. So I'm going to start with subtracting 4. Subtracting 4, absolute value of x plus 7 is less than 8. Now I'm going to write my two inequalities. So I have x plus 7 is less than 8. X plus 7 is greater than a negative 8. I have to switch the inequality sign as I have the multiple. And so now I have two little inequalities to solve. So I subtract 7, x is less than 1. Subtract 7, x is greater than a negative 15. So now I'm going to get my number line. Oops. So now I have to be sure to graph these correctly. So negative 15 comes before 1. I have x is less than 1. So here I am at 1 going less than. This is saying x is greater than a negative 15. Open circle, greater than, so it's the stuff in between. So I have negative infinity to 1, and then they're parentheses because they're both open circles. All right, number 17, write the interval notation for the solution to this. And so all we want to really key in on is that we are seeing it is a greater than or equal to. A greater than or equal to is what part? So get your highlighter pen. And what part is it that's going to be greater than or equal to? It's the stuff that's above the lines. So this is above, and that's below, above. So where are our points? So let's go in and see what we have here for our points. This is showing you this is 1, and so that's 2. That's negative 1, negative 2, negative 3, and a negative 4. So where does this graph begin at? It begins at negative 4, and where does it go to? A negative 2. This is a greater than or equal to, so I'm going to have brackets here, union, where does the graph begin at? 2, and where does it go to? Infinity. A bracket at 2, parenthesis at u, or parenthesis at infinity. Okay? I have two sections highlighted. I have this highlighted. Whoops, I don't want to move that. I have this thing highlighted, and I have this thing highlighted here, that whole thing. And so you can see that I have two sections highlighted, therefore I have two inequality, two parts to my interval. On number 18, here I'm looking for what is less than 0. So the main thing that I want to pay attention to is what is less than. This is what I'm paying attention to. And so what is the stuff that's all below the line? And so this is below the line, and this is below the line. And so what are those points? This is telling me again that this is 1, and there's 2, and that's 3. And I'll label 2. I'll take that out. Oops. I'll stick a little highlight in there. And so this is 1, 2, this is 3, 4, and this is 5. And this is negative 1, negative 2, negative 3, negative 4, and negative 5. So where does this graph begin at? It starts, where's the highlighting? At negative 5, and it goes to negative 3. It's a less than, so it's going to be open. I have another highlighting section, so union. It starts at 3 and goes to 5, and again, it's highlighted. Almost done, 2 more. So here we're multiplying. This is stuff that we did the very first day with multiplying, and we noticed right away that the x plus 3 and the x plus 3 are the same. So I have x plus 3 quantity squared. Now you notice that they're exactly the same thing except one is a positive and one is a negative. So that means the middle term is going to cancel out. So I can let that go. So all I care about now is this last term right here. And so I have a positive times a negative. That's going to be a negative. And radical 2 times radical 2 is 2. And so now that's the pattern. X squared, that's a 3x. I double it, I get 6x. And 3 squared is 9 minus 2. X squared plus 6x plus 7. And so that's my final answer. Remember, if you're having a hard time, you don't get the pattern, write it out 2 times, and do all the multiplication. It's sure going to save you a lot of time if you memorize that pattern. And then here we're going to factor this. I recognize that I have a perfect square, perfect square, perfect square. 36 is a perfect square, x squared is a perfect square, 49 is a perfect square, and this is a difference. That is a subtraction. So I can factor this pretty fast as a difference of 2 squares, which is 6x plus 7 and 6x minus 7. And ladies and gentlemen, that concludes the taping of Unit 1, Review A. I hope you find it beneficial, and good luck on your test on Friday.